To make the battery, you need an anode and a cathode. The anode is the metal that is more active, so it's higher on the activity series. Magnesium is our anode, which is oxidized. It causes tin to reduce, so it's the reduction agent too. Tin is our cathode, which is reduced. It oxidizes magnesium, so it's the oxidation agent. We put the magnesium in a magnesium nitrate solution and the tin in the tin chloride. We also made a salt bridge from the filter paper soaked in potassium chloride, which is an electrolyte solution. The salt bridge maintains a balance in the charges between the anode and the cathode half cells. The chlorine reacts with the magnesium, and the magnesium nitrate and the potassium reacts with the tin chloride. Arrange the battery like this with the salt bridge in each solution and the alligator clips on top of the anode and cathode. When the alligator clips and wires connect to this voltage reader that connects to the computer and reads the amount of electrons. This is what the setup looks like before the salt bridge is added, and the two half reactions occur in the two half cells. One is oxidation and the other is reduction, so it's a redox reaction. The oxidation equation is magnesium, which is a solid, to magnesium 2 plus aqueous plus 2 electrons. And the reduction equation is aqueous tin 2 plus 2 electrons to tin solid.
Oh hey, it doesn't reach yet. Oh no, we need more. Maybe we could fill it with more of this and then move it over a little. Because there's no more of this. It reaches? It reaches. It reaches. We're recorded. Okay. Alright, the salt bridge reaches. Okay.
Yeah. It's different than power.
How's it doing?
Yeah, I don't know.
Is anything happening? Did it say that before we started?
No, I didn't do it before we started.
Alright. Well, that's how many volts it has. Put these things on the wrong spot, on the wrong one, so we flipped them, and it's not any higher now, but it's positive, and it was supposed to be a positive number, but that's half the voltage it's supposed to be. So this is what the number is supposed to be, 2.23 volts, but it says that.
Electroplating is done when two metal terminals, called electrodes, are passed through an electrolyte, which is a positively charged solution. When a current is sent through the electrodes, the electrolyte starts to split up and deposits some of its ions onto the electrodes in the solution. Electroplating occurs on the outside of the metal only. We could have done this in our experiment if we put both of the electrodes into either one of the solutions. Baghdad batteries were a series of 3 artifacts found that resembled modern batteries. They were made of terracotta pots about 3 inches tall with a 1-inch opening, and had a metallic center and an acidic solution on the outside of that center. On the inside there was a rolled piece of copper foil, very thin, scrolled around a metallic center of iron. On the outside of the metallic center there was an acidic solution. The iron is isolated from the copper by a stopper made of bitumen. Lithium-ion batteries are a type of rechargeable battery. Because of its high density and low maintenance and its long-lasting, it's a very common and efficient battery. The lithium ions go from the negative electrode to the positive electrode during a discharge. It does the opposite during charging by going from the positive electrode to the negative electrode. They are used a lot in common technology such as phones, camcorders, and music players.